Pentane and butane. What is the obvious difference, Jabu? Yes.
Pentane has 5 carbons and butane has 4.
Okay, so correct. But I want you to touch one of 3 words. So go back to, I think, is it page 19, page 17 in your notes? Page 16. All right, go to page 16. So we are there at the third thing, the third independent variable. All right, so I want you to, it's true that the one is 5, the other one is 4. I want you to say the word or write the word, something like on a chain length or surface area or molar mass. Okay, so even though the one is 5, the one is 4 is correct, but we want to say the molar mass is bigger or whatever. Now, why in this specific one do we want to mention molar mass? If you look there at the top, I'm going to put this on in a moment. I just need to give it like 3-4 minutes. If you look there at the table at the top, they give you, they're all the way on the right, they give you the molar mass. Okay, so that is why we are going to refer to molar mass, because they give it to us. So it's that, like, please use this now. Okay, so if we compare butane and pentane, you see that pentane has a higher or a bigger molar mass than butane. Okay, so that's the first bullet point that you are going to write. You're going to say pentane has bigger molar mass than butane. Okay, so that is the obvious difference. Are you writing down, Declan? Pentane has bigger molar mass than butane. Right, then what is the next thing that you must mention? Princess. Okay, but are you just going to say intermolecular force? What are you going to say regarding it? Which one has the stronger intermolecular force? Between butane and pentane, the shorter one. Princess, this is a worry for me because we did this now, I think 3 times, 4 times in this whole chapter, because I explained this also on page, I want to say page 4. They got the same type of intermolecular forces. They got both of London forces. Oh, you are grateful. 5. Then we discuss the length of the molecules. Can I show you a video? Princess, then you must catch up. What did we do in the lesson? Tawana, what are you going to say regarding the intermolecular forces? Why do you say that? Nia! Oh my word, guys, we've done this last year, a whole chapter. Then we did this on page 5. I showed you a video and we discussed it and I drew stuff on the board. And on page, I'm going to be with you now, Boki, because you need to save me. Otherwise, I might just walk out of this classroom. And we did this. Where did we did this? We did this here. We spoke about intermolecular forces. I made sketches. Did you also do this? Yes. And I discussed this. Yesterday too. That has to do with the side chain, but yes. Yeah, but that gets to a higher boiling point. Why does it have a higher boiling point? That is the question. Okay, so save me, Bookie. Say again. Which one has a stronger bond? Stronger forces, sorry, stronger forces. Pentane or butane? Mama? It's more carbons, it's longer. So that's why it's stronger. Alright, so we're going to say that both, we said all the alkanes have London forces. So we're going to say, even though, how do you spell though? Even, like that. Even though both have London intermolecular forces, pentane has a stronger intermolecular forces. Okay, so why does it have stronger forces, pentane? Because it has a bigger molar mass, because it is longer. The longer it is, the stronger the forces. Then that golden sentence, Mosi, regarding the energy. Right. Thus, more energy needed to overcome intermolecular forces between okay, now in that sentence, I want to say everything is important. Okay? You can't say that more energy is needed. You can't say that more energy is needed to overcome intermolecular forces. You must say that more energy is needed to overcome intermolecular forces between pentane molecules. Not inside pentane. You don't want to break the bonds. Between pentane molecules. That whole sentence, every word is important. And then our last point, is thus pentane has higher boiling point. I'm going to abbreviate a bit now. Are you guys still asleep or? Do I always see you so early in the morning? No, luckily not. Alright. Then the next one, they say there, methyl propane is an isomer of butane. And we saw that. Why is it an isomer? Because they have the same molecular formula. Liakwe, what type of isomer or isomers are they? Your options are chain, positional or functional. Let's do elimination. Functional is when the functional group or the homology series change. Same homology series, same functional group. So it's not functional isomer. Positional isomer is when the position of the weird thing changes. Position of the side chain, position of the functional group, whatever. Did the position of the functional group change or the position of the side chain? No, because this one doesn't even have a side chain to change where it sits. So what type of isomer is it? Chain isomer, because the length of the parent chain changed. This one had 3, this one has 4. Okay, so they are chain isomers. Now they ask, explain why its boiling point, so methyl propane, is lower than that of butane, despite having the same molar mass. Alright, now even though it only counts 2 marks, you are still going to mention those 4 things. Okay. So as question B. Now, just because I am lazy, I don't want to write methyl propane the whole time. I'm going to just number these. I'm going to make this A, B, C, D. Then we can just say B has a higher than C. Yes. No, because I don't get your question paper back. But what you can do is you can at the beginning of your question say, I'm going to let A be da da da, and I'm going to B let da 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 da. And then you can speak about A and B. But most of the time they do give it to you as compound A, compound B, compound C, compound D. Okay. Ah, la 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 la. Tiamo. What's the first thing that we must mention? Or what's the obvious difference between the two? While you are thinking, Boki?
Sometimes because of the numbering A, B, C, later on in the question they ask us to determine what's the substance.
Yes, they can do that. I want to practice questions like that. In that packet that I handed out yesterday.
So you have to have because looking at that,
Yeah, but that's a difficult question, but we're going to do that actually, no, think about it, in the next chapter of this chapter. We're going to determine it. You'll see. It's difficult, but it's possible. Yes, Yamo? What's the difference, the obvious difference? No, the molar mass is the same. Obviously, is the boiling point the difference. The question is, why is the boiling point lower than? That is our conclusion. We're going to say it is lower than because of blah, blah, blah. What's the obvious difference if you look at it like this? What did I just discuss with Liafwe for like 5 minutes? Jabu. Yes, butane is a straight chain molecule and methyl propane has a side chain. So it has to do with the surface area. Okay, that is now the that I explained yesterday. Okay, so the obvious difference is B has a side chain. Methyl is a side chain. Okay, B has a side chain, and thus a smaller surface area, and C is a straight chain molecule. Okay, stating the obvious difference. Then the next thing is the intermolecular force. Declan, how will that impact or influence the intermolecular force? Which one will have a stronger or a weaker one? Say again, which one?
No, sorry, C. No. C will have a stronger. E, yeah, E, sorry. Methyl propane will have a stronger intermolecular force than butane because it has a higher boiling point.
Okay, but remember, you can't say because there's a higher boiling point. That is what we want to prove. Okay, but yes, your third guess was correct. Okay, so we're gonna say because. Okay, but sorry. So just look at how I'm answering this question. They ask, why does methyl propane have a lower boiling point? So normally we say, thus it has stronger forces, thus it has. Now I'm going to say this one has weaker forces because I want to point to which one has a lower boiling point. Okay? So I'm going to say B has weaker intermolecular forces than C, even though they both have London forces. Even though both have London forces, B is weaker because it has a side chain, but we already said that it has a side chain. What's another word for side chain? Something group. Alkyl group. So you can either speak about an alkyl group or a side chain. Mooi mama. Alright. Then how will that impact the energy, Jabu?
There's more energy needed to overcome the process of
Between? Yes. Okay, so that's true. Thus more energy will be needed to overcome intermolecular forces between C's molecules. But we are doing now the inverse. So we don't want to say more energy, we want to say less energy. So which one will need less energy? B. So we're going to say thus less energy and then thus it will have a lower boiling point. Okie dokie. Going. Gone. Not gone. Okay, I see they ask, why is it important when comparing the boiling points of butane and methylpropane that the compounds have identical or very similar molar mass, princess? Okay, so I'm going to go up. So when we compare these two, why do they need to have the same or very similar molar mass? My clue to you is, we want to see who is the fastest in the school. No, that's not why they need to have the same molar mass. Yes, Mama? Sorry?
because they have the same amount of carbons and hydrogens.
Yes, but you're not saying the thing I want you to say. No. Yes, it's true, but no, that's not what you want. You must say. Yes? Yes, but it's still not what I want you to say. No, the question is, why must it be the same? Why is it that the mass must be the same, the number of carbons and hydrogens must be the same? Why? But why? Why is it important that they must be? Not what does it mean if they have the same number of carbons? Yes. Yes, you're closer. Will it be fair to compare the two? If the one is very long with the side chain and the other one is just short with the outer side chain? No! because then we have two variables. We have two independent variables, and then it's an unfair experiment. Okay? So why must something be kept constant? Why must the molar mass be the same? To make it a fair experiment. You cannot have more than one variable. Nee, dit kan nie wees nie. Huh? Nee, dit is verkeerd. Dit is verkeerd. Are you writing down? Did you write that down? To make it a fair experiment, there cannot be more than one independent variable. Dit kan nie wees nie. Yes? Independent variable. Okay, and then which compound in the table has the highest vapor pressure? Highest vapor pressure means it evaporates the fastest. It will be propane. If the boiling point is low, it means it evaporates quick. So it will be propane. Propane. Yes. Like the lowest. No, I haven't found the temperatures like that, so I don't know. Alright, that page that I handed out yesterday, because I see some classes are moving. That page that I handed out yesterday, I want you to do two questions. The first question is, now let's just start. Let's do on question 9, on question 9. On page 9, question 1. Alright, and I want to say something in question 1. There you see compound D and compound E. Compound D and compound E are compounds that does not look familiar. Okay, it's because that part of the syllabus was taken out of code. Okay, so D and E you do not need to know. Because of that, you do not need to do question 1, 1, 2, 1, 1, 2, and 1, 2, 2. You do not need to know. 1, 1, 2, and 1, 2, 2. You do not need to do. Okay, and then I want you to also please do on page 70. I want you to do question 2. I think I did upload the video. No, I didn't.